For this class, our focus is the quotient rule. So how do we derive the formula for quotient rule using the first principle? So we have quotient rule. Now consider a particular function y equals u over v. This is the division of functions, but it is called quotient rule. So this is our first function and this is our second function. Of course, they are functions of x. So the y dx is going to give us v du dx minus u dv dx all over v squared. How do we come about this particular formula? I will show you in our next slide. So let's say we have this function y is equal to u over v. From first principle, we'd have that y plus dy equals u plus du all over v plus dv. And from this, we can make the y the subject of formula. We have u plus du over v plus dv minus y. So dy will give us u plus du over v plus dv minus u over v. Now since we have this, we can decide to look for the LCM. The LCM, of course, will give us dy equals u plus du over v plus dv minus u over v. The LCM is v into v plus dv. So if we look for the LCM, we have v into u plus du minus v plus dv times u. Now, opening the bracket, we have the y equals uv plus v du minus uv and minus u dv all over v squared, or let's put it v into v minus dv. Okay, now having said that, we can slash the u out, u and v out. We now have dy equals v du minus u dv all over v into v minus dv. Okay, now dividing through by the x, it will give us the y over the x equals v du over the x minus u dv over the x, then all over, if we decide to open the bracket in the denominator, we have v squared minus v plus v dv over the x. Now this is what we have, and dividing through by the x gave us the access to looking for the limits of the left hand side. So limits of the y dx as the x tends to 0. Of course, I said it will give us the y over the x, that is the full differential. And in this case, if this happens, du will tend to 0 and dv will tend to 0 as well. So this equation over here gives us the y over the x will be equal to v du over the x minus u dv over the x all over v squared, where the denominator over here will tend to 0. And I've already explained why I said all these will tend to 0. Now, if you compare what you have here to what we had initially, you will realize that they are the same. So both from formula method and from the first principle, we are still going to get the same answer. Invariably, the quotient rule states that the y dx equals v du dx minus u dv dx all over v squared. And that is the end of today's class. In our next class, we'll solve an example under the quotient rule, which you can use as the basis for all other examples whenever you come across them in any examination. So see you in our next class.